Alright, let's do some practice with evaluate logs. So, starting with our second example, log base 5 of 125 equals to m. So all what we have to do is first write it into exponential form. So, our base is 5. And then what the log was equal to, that's our exponent. So 5 to the m power equal, now this is our exponential, so whatever our exponential will equal to what was next to the log. So log base 5 was next to 125, so that's what our exponential form is going to equal to. So 5 to the m power equals to 125. Now, based on from memory, I know that we can convert 125 into a lower common base or lower same base, and that same base would be 5. So 5m equal to base of 5, and then whatever it is, so 5 to the third power will be 125. And then once you have the same base, then all I have to do is just focus on the exponent. So my exponent is on the left is m, and then my exponent on the right is 3. So our base, our exponent for m equals to 3. So that's what we're looking for. Now the reason we can do this is because it has the same base. So let me explain about that. So for example, 5 squared is 25. And then the only way that it can equal to itself is if it's 25. That's a true fact. So 25 equals to 25. So then it must be true when it's 5 squared. 5 squared is the same as 5 squared. So again, this is the concept that whatever it equals to, it has to be the same on both sides. So 5 squared equals to 5 squared. Same thing as 25 equals 25. So that means if it's the same base, then the exponent has to be the same. So if it is 5 to the x power, then therefore if it's the same base, then the exponent has to be the same. So therefore 2 equal to x. So again, I got this 2 from that exponent, and I got this x from that. So that's the concept of being equal on both sides, or being the same on both sides. So let's do the same process for log base 6 of 36 equals to w. So first step, write in exponential form. So our base is 6, and then whatever the log was equal to, that's the exponent, so w. And then what was next to the log was 36. So 6 to the w power equals 36. So now all we have to do is look for common base or same base. So I'm going to rewrite the left side and then convert 36 into a lower base where it's the base of 6, and then based on memory, 6 to the second power is 36. So that is true. Now once we have the same base, therefore if it's the same base, then the exponents has to be the same. So therefore w equals 2. And then there we go. That's how you're going to evaluate with logs, or convert from log to exponential and solve for exponents. So that's basically what it means by evaluating logs. Alright, same process, evaluating logs. Now, before we worked with whole numbers. Now we're going to work with fractions. So in our fourth example, it's log base 3 of 1 over 81 equal to x. So, alright, since we're working with fraction, it doesn't change anything. It's going to be the same process, just an extra step. So let's convert into exponential form. So 3 is our base raised to whatever whatever the log equals to. So x. So in our exponential form, 3 to the x power equals to 1 over 81. Now, so let's work with the 81 in our denominator. So we know that based on memory or based on what written before, 81 can be rewritten into a small base of 3 to the 4th power. So now we have 3x equal to 1 over 3 to the 4th power. Now, I can't have a fraction because if it's not like a whole number, then we can't solve for the exponent. So first we need to convert this from a fraction to a whole number. So based on exponent laws, we can rewrite 1 over 3/4 as 3 to the negative 4th power. So whenever you have a base with an exponent in the denominator, you can rewrite it where you can bring it up and change it to a negative. So when the base is the same, then all I have to do is just set the exponent equal to each other. So x equals 4. So again, in order to work with fraction, you need to remember your exponent laws, exponent rules. So just a little review. So for example, say let's do 2 to the negative 3rd power. So whenever you have 2 to the negative 3rd power, in order to work with that, in algebra 2, you would convert into a positive exponent. So in order to convert into a positive exponent, you bring it down to the denominator. So right now, 2 to the negative 3rd power is the numerator. So if I convert this to a fraction, we see that 2 to the negative 3rd power is in the numerator spot. So in order to convert this negative exponent to positive, you're just going to bring it down to the denominator. So 1 over 2 to the 3rd power. So again, all I did was just bring it down to the denominator. I didn't switch because sometimes you might have another variable or a number in the numerator. So all I did was just bring it down to the denominator and then work it out. So 2 to the 3rd power is basically 8. So 2 to the power of negative 3 equals to 1 over 8. Now, here we're starting with a negative exponent and then bringing it down to the denominator. But the reverse order can be the same. I can change this to 2 to the 3rd power, and then if I want to bring it up to the numerator, I change it to negative. So that's what we did here. Now, working with example 5, we have log base 2 of 1 over 32 equal to x. So first step, writing in exponential form. So our base is 2 and our exponent is x equals to 1 over 32. So again, we have a fraction. So I'm going to write the left side again. Now keep the numerator first, and then we know that based from memory, 32 can be written into a smaller base of 2. So base of 2, and then from memory again, we know that 2 to the 5th power is 32. So now we have the same base, but 2 to the 5th power is in our denominator. So we need to bring it up into the numerator. So in order to do that, we need to change the exponent into negative. So 1 over 2 to the 5th power is the same as 2 to the power of negative 5. And then since we have the same base, x equals negative 5. And then that is our answer. And then I noticed there was a little mistakes over here. It was actually x equals to -4. So just like that, I accidentally forgot my negative. So be very careful. Don't forget your negative. Don't drop it. Don't lose it. If it equals to a negative, keep that negative.